Hello. You're welcome to Phosphate Academy. Today we have 15 minutes of physics for our ordinary and intermediate levels. We will be looking at pressure. We will be looking at force, the relationship that pressure has with force, the relationship that pressure has with the surface area. And we'll look at one or two questions, and we are going to solve that questions, and we'll be able to have some understanding about pressure. Now let's start. What is pressure? Pressure, I'm using the symbol P, is defined as the average force acting normally per unit surface area. The average force acting normally per unit surface area. So our F here is the average force. Average force acting normally per unit surface area. Our area here is such that we measure it in meters. Our force is measured in newtons. So pressure is our force acting normally per unit surface area. When we say normally, if I have two lines, call this line 1. If I have another line, so that is actually cutting line 1 at 90 degrees, then we say that this is a normal line. So this line is normal to line 1. So pressure, therefore, the force must act at 90 degrees to the unit surface area. So pressure will be measured, therefore, the unit of pressure P will be equals to the unit of force, which is Newton. This area is meter square per meter square. So the unit of force, which is Newton, per meter square, which is the unit of the area. There are also going to be higher units of pressure. Higher unit of pressure. We will talk about the kilo. This unit, which we call Newton per meter square, is called the Pascal. And therefore we can generalize and say that 1 Newton per meter square is equals to 1 Pascal. So we can say that 1 Newton per meter square is equals to 1 Pascal. So there are also higher units. There are higher units of pressure. Kilopascal, whenever you hear of kilo, it means 1000 Pascal or 1000 Newton per meter square. We also have 1 megapascal. Mega will simply mean 1 million Pascal. 1 million Pascal. So you see that from our equation 1, we can see that pressure is directly proportional to the force. What does that mean? This implies that if we increase the force, then we are going to do so by increasing the pressure. And we also see that pressure is inversely proportional to the area, the cross-sectional area. What does this imply? This implies if we increase the area, we do so by reducing the pressure. Yes, we're doing so by reducing the pressure. So this is going to explain why when we want to use our knife, we will use a sharp knife. So the sharp knife will have a smaller surface area. So when you apply the force, the pressure will be high. Given that when you reduce the area, this also implies that if the area, the cross-sectional area is reduced, it will lead to an increase in pressure. This is increase in pressure. Increase in pressure. That is the relationship that pressure have with force and surface area. Now look at somebody here. You can see the shoe. Look at this shoe. The surface area of the shoe is quite large. So the person feels comfortable working with a shoe like this that has a surface area that is large. Let me take another instance. Can you see this other shoe? I want you to take note on the high heel. Such shoes, when you move with them, they are going to be digging the ground. The smaller surface area of this particular high heel shoe will have to exert a very high pressure. The pressure here will be very high. So you observe that this shoe will be digging the soil. But for this other shoe that is flat, occupies a larger surface area. So the pressure here is going to be small. I want you to note that. What about this other woman here? Will the woman feel comfortable working on swamping areas? Answer is no. The woman is not going to feel comfortable working in a swamp or in a region that is muddy. In a muddy region. Why? Why will the woman not feel comfortable? Because the surface area here where the pointer is very small. Very small surface area will lead to a very high pressure, and therefore you observe that the woman is going to sink into the soil. The woman will sink into the soil and will need some force to come out of the soil. That is the relationship that pressure have with the cross-sectional area. A woman weighs 64 kilograms. A woman weighs 64 kilograms. So the 64 kilograms is the mass. Mass of the woman equal to 64 kilograms. Stands on her 2 feet of total area 0.8 meter square. So the area here is 0.8 meter square. Can we try to see the woman? Here is the woman. 2 feet on the ground, and you observe that one, these 2 feet, it means that one of these foot will occupy 0.8 meter square divided by 2. So when we multiply that 0.4, we will be giving us 0.4 meter square. So you observe that one. When we multiply this 0.4 by 2, will give us 0.8. So this question is very easy to solve. We need to first get the weight. Weight of the woman will be the mass times acceleration due to gravity g, and the mass is 64 kilogram, and the acceleration due to gravity is 10 Newton per kilogram. So our answer here will simply be 640 newtons. Will be 640 newton, because per kilogram will cancel kilogram. Now, what is pressure? Pressure P is equals to force all over area. Pressure P is equals to force all over area. Force all over area. And we already see that the force is having the right unit. So we can say that this is equals to, the force is 640 newtons divided by 0.8 meter square. 0.8 meter square. Now I just want us to punch the calculators and get our answer. 64 divided by 0.8. Answer is going to be, our answer is going to be 80 newtons per meter square, or 80 Pascal. This is our answer. This is the pressure. What is the pressure she is exerting on her support? This is the pressure that this woman is exerting on any support, given that is using the 2 legs. If she stands on 1 foot, what will be the pressure exerted, assuming that the 2 feet has equal area, surface area? Imagine this is a woman. Is now standing on 1 feet. Now we already know that our weight, which is the same like our force, is equal to 640 newtons. The woman has not changed the weight. The weight is still there, but in this case, standing on 1 feet, one foot. And the total weight now is over a cross-sectional area of 0.8 meter square over 2, which is 0.4 meter square. This is the woman. So this is the area, because using one is using just one. Look, this is the one of the foot. So simple. So we can see that our pressure can be calculated from force over area, and this will be 640 newtons. In physics, you take note of unit. Take note of unit, please. And our answer is going to be, of course I can guess the answer. Since the area has been half, pressure should double. So instead of 80, I expect to have 160. This is incredible. 640 divided by 0.4. So 1,600. Okay, 1,600 600 Newton per meter square. 1,600 Newton per meter square. Let me check the answer I got initially. 640 divided by 0.8. This is important. I wanted to see whether you are able to do the calculation too. And so if we come back here, we will see that our answer here is not 80. Our answer here is going to be, our answer here is not 80, but it is going to be 800. So the answer here, you have done the calculation. I wanted to see whether you are working with me. 800. The same 800 Pascal. I want this side to be as interactive as possible. So now you can see when the pressure, you can see that when the area was equals to 0.8 meter square, our pressure called P1 is equals to 800 Pascal. Now, when the area was half, area over 2 was half to 0.4 meter square, our pressure was multiplied by 2. So if we call this P1, our P1 has been multiplied by 2 to 800 Pascal times 2. And the answer is 1,600 Newton per meter square, or just say Pascal. 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 That's it. Or 1,600 Newton per meter square. Remember, this lesson is for our, ordinary and intermediate levels. Our interest is for you to be able to enjoy, physics. Thank you. Have a wonderful day. That is the woman. We have come to the end of our lesson, and we are saying that have a great day.